So why don't we talk about the advantages of both of those types? You know, you have subtractive manufacturing with the CNC machining and the mills and the lathes, and then you have the ability to create a really quick prototype using the 3D printing. So Dan, why don't you talk to me about the advantages that each of those offer in terms of the precision and the customization for adaptive athletes' prosthetics needs, specifically for those products?
Yeah, there's a lot of things that come to mind there. I mean, one of the first things, and Mike nailed it, it's if you have a CAD model, you can send it through for quoting, get quick feedback from us, and then that's how close you are to already getting a part. So that barrier of entry to getting to a physical thing that you can hold in your hand, actually test a physical part, we try to make that as low as possible. And then the speed element is really key in there too. From a CNC perspective, I suppose one of the advantages is that your part is being cut from a raw block, a solid block of that material that you'd like. When you see the quote itself, you get this accurate feedback. So if there's anything from a manufacturing perspective that might be a little bit challenging, you see that right up front. You can decide, is this something I can live without? Do I need to change, or do I maybe need to pivot how I'm looking at having this part manufactured? And then kind of the other side of that coin is additive, obviously, where the designs are almost infinite. But when you're talking about price, you're talking about speed, there are different considerations that come into play. So we get a chance to work on these sort of more bulkier, blockier, more right angle focused kind of designs through the CNC side. And then we get some really crazy organic shapes. You should see some of the things that like AI generates from a design standpoint too, that we've had a chance to work on both through CNC and through additive on the 3D printing side. So it really is a very wide world of manufacturing capabilities. And it's just a matter of, hey, what is the design? What is the demand on the part? And how can we help make it?
Right. So speaking of that, how do you choose? I guess this could be a question for either one of you. How do you choose the material? Because I know sometimes you want something that's more strong compared to something that's lighter. So what would you say would be the parameters? Is it really the end use for the part, for the component?
Yeah, I mean, there's a couple of variables, but our two basics are the strength of the material and the cost to produce it. We make the majority of our parts out of 7,000 series aluminum, just because it is lightweight, it's fairly strong, and it's cheap to machine compared to like titanium. I would love to make a whole leg out of titanium, but the cost would be about 4 or 5 times machining costs plus the material differences. So those are the two main factors that we look at. And then if we're doing additive, that kind of depends on the price as well, and the weight and the strength. So yeah, depending on those factors, we kind of make a decision on what works best.
Gotcha. Dan, can you explain to us and to the audience how that CNC machining that you guys offer, how you're able to only make a few, and like you were talking about, high runs don't have to happen. Tell us about that.
Yeah, so I mean, a lot of what we do is, I mean, originally we were built around that, right? We had a really keen focus on prototyping and speed in particular, and so trying to bring those two ideas together, our founder Larry Lucas basically started figuring out how to code and how to actually write the software programs that have been adapted and modified and improved over the years. And so when we get a part like that, what we're able to do is we don't need to take a really long time working with a skilled machinist. And as you might not be surprised to hear, those folks are scarcer and scarcer as time goes on. But so what happens is we get the file, we bring it into our system, it goes into our proprietary software where we have all of our cutters, we have all of our block sizes, all the different elements of that manufacturing process live in that digital environment. And then we take a CAD file like something Mike and his team would send us. We apply that with our cutter sets, all the different options we have, and we basically pre-manufacture that part. And so we know that we can very quickly redo that design. We can very quickly bring in a new design. That software, knowing the fixed parameters it has to work within from the manufacturing standpoint, allows us to move extremely quickly. So there's not as much of a requirement for us to say, oh, we're going to put in a lot of this design work, we're going to put in a lot of this effort up front, and then you need to have that 100 part kind of order just to make sure it's worthwhile for your team. our system does so much of that heavy lifting when you talk about pre-planning manufacturing, that it's really, really easy for us to say, yeah, we're more than happy to take on a one-off, a two-off part, because it's basically all the same to us and the software does all the work behind the scenes.
It's so impressive. I mean, what you guys are capable of is just mind-blowing. Being able to, load a part up, and then it'll redline an area that's not machinable, and just knowing that within an hour of submitting it is so valuable. So then we can pull it and we can make minor adjustments and resubmit it, and then it's so fast compared to submitting a file to a machinist, and he goes through it for a week and figures out how to make a fixture for it and all that. It's just night and day difference.
Right.
Yeah, we like to think that design element can be sped up, and then we can also make it pretty darn fast. So you bring those two pieces together, and before long, you can iterate 5 different times in the span of a couple weeks, whereas usually, historically, that might take a couple months or somewhere in that time frame.
Yeah, we've come a long way. I mean, we've come a long way in a short amount of time. So why don't we talk about the quality control measures that are implemented during this machining process? Can you tell me about that so that we have the highest standards of performance and safety in the final product? Dan, I'll give that one to you.
Yeah, absolutely. From a manufacturing standpoint, like on the floor itself, we have processes to constantly monitor machine and tool health. So, as we're running tools, we know we have a lot of data. We've got a lot of actual, probes and sensors within the machines themselves. So if there's ever a point where something is off from a block standpoint, if we're ever worried about, cutters getting dull or, running the risk that they might break, all of that is already built into the process. So it's this really finely automated system where the second a machine is down, a red flag goes up, and we've got maintenance going in and taking care of whatever the issue might be. And when you have as many machines as we do, our plant here in Brooklyn Park, Minnesota is over 330 machines. And when you have that amount of machines, you don't, as we said earlier, we don't have a skilled machinist who's having to run each one of those machines, because the software does so much of that heavy lifting up front. We can have an operator run anywhere from about 15 to 20 machines at once. An operator will be able to scan a job sheet, scan a barcode, and then scan a machine itself. And if all those pieces don't line up, the machine won't even start. So it makes sure that there's that kind of fail-safe mentality as a part is flowing through the system itself. And then when parts are finished, we've got a pretty standard inspection process that ensures that geometric compliance. But we do make sure that, we're looking at everything going through, whether it's the parts itself or even just those little details within the system too.
How do you see CNC machining continue to shape the future of the prosthetic technology and athletic performance in the adaptive sports industry through innovations like those that Mike has done by Adapt?
Yeah, I mean, I guess the short version is just facilitating innovation and doing it as fast as humanly possible, so that the next greatest, version of an action knee, like what Mike's team is working on, or the next greatest prosthetic that's coming along, or the next greatest design, that we can help make that a reality as quickly as possible. When you think about CNC or even just 3D printing, I love Mike's story in that all he had to do was kind of bring us a CAD model, and we could help in some small way contribute to this really awesome and this really cool cause, this really great product. And so we know that there will be other companies that, if they're in slightly different space or, similar prosthetic space, they're going to be pushing that envelope and pushing each other to really innovate. And that's kind of why we do what we do here. I think that we at Protolabs take a huge amount of pride in even getting a chance to have a little bit of, experience a little bit of the story that Mike's going through and seeing some of these great things that are coming on the back end. So, basically our thought process is whatever we can do to help make those parts and those designs and, those things that just start as an idea and turn those into a physical reality that eventually someone's able to do something really cool, like win a gold medal with. I mean, that's exactly why we do what we do at Protolabs.
Yeah, and I'm pretty sure Logan, that was that little motocross kid. Those prototype parts came from your guys' shop.
Awesome. I love that. That's so cool.
I love it. That's terrific.